You are up to 8.7, which is multiplying a polynomial by another polynomial. And in the beginning, what we are going to be doing mostly is multiplying a binomial times another binomial. So a binomial has two terms, and so each of these are going to have two terms. So there are different ways to talk about doing this, and I'm going to talk about both of them. The first way to do it is talking about distributing twice. So basically what we're going to be doing each time we do it is distributing twice, and I'll show you what that means. Here's my first binomial, x plus 3, and my second binomial, x plus 2. So they're both in parentheses. I'm going to take the one in the first parentheses, and I'm going to take the first term, which is x, and I'm going to distribute it twice. First, I'm going to distribute it here, then I'm going to distribute it here. So that would give me x times x is x squared, and then x times 2 is 2x. Now, now I have to take this second term, and I have to distribute that twice. So I'm going to distribute it here and distribute it there. So that gives me plus 3x plus 3 times 2 is 6. Just remember you are always multiplying. Whenever we do this, or not always, but usually when we do this, we have to look to see if the middle two terms are like terms, and then we combine them. So to combine those two terms, 2x plus 3x is 5x. And this is our final answer. It will just say to find the product. In the beginning, the directions will just say find the product. And you have to know you're multiplying just because you have those two sets of parentheses next to each other. And then this is the answer. Now, it's also referred to quite often as foiling. And you'll hear me say, make sure you FOIL it. Sometimes I say distribute twice, sometimes I say FOIL. But either FOIL is a really common term for doing what we're doing right now. FOIL means first, outer, inner, and then last. And it's talking about which terms you're multiplying. The first, the outer, the inner, the last. So I'm going to show you what that means. I'm going to take x plus 5 this time and multiply it by x minus 4. So we could think about it as distributing twice, but here's what it means to FOIL. In the first, when it says first, it means you're going to take the first term of each binomial and multiply them together, and that would give you x squared. When it says outer, it means you're taking the outside terms. This is one on the outside, the ones on the outside of each of those binomials. So this is the outside on the left times the outside on the right. That's x times negative 4, so that gives me negative 4x. And then it says inner. So the inner two terms means the two that are in the very middle. I'm multiplying 5 times x. That's plus 5x. And then last, that means the last one in each binomial. This one times this one. And it is a 5 times a negative 4, so that's a negative 20. Again, I look to see if I can combine the middle two terms, and I can. Negative 4 plus 5 is x. So I have x squared plus x minus 20, and that's my final answer. Okay, for my third example, I'm going to start with 2y instead of just y. 2y plus 3 times 6y minus 7. And I'm going to distribute distribute twice or FOIL. So that means I'm starting with the first term times the first term. 2y times 6y is 12y squared. Then I'm going to do the outer. 2y times negative 7 is minus 14y. Then I'm going to do the inner. And I'm distributing the second thing now. 3 times 6y is plus 18y. And then I'm going to distribute the last two. The last from here, the last from here. 3 times negative 7 is minus 21. So as always, we just have to be really careful of the negatives. Now I'm going to combine the middle two terms, negative 14 plus 8. So that gives me plus 4y squared minus 21. Okay, I'm going to give you another example, just making the terms a little bit more complicated. 3a plus 2b. I'm going to multiply that times 6a minus 5b. Starting with, I'm going to distribute the 3a here. That gives me 18a squared. So just always remember if there's an a in both of them, in the first terms, then it's going to be a squared term. Then I'm going to distribute the 3 over here to the 5b. That gives me minus 15ab. Then the middle two terms, it's 2b times 6a. So that's 12ba, but that's the same as 12ab. So I'm going to write it as plus 12ab. And then the last two terms, 2b times negative 5b, is negative 10b squared. Once again, my middle two terms are like terms, so I'm going to combine negative 15 plus 12. I have 18a squared minus 3ab, and then minus 10b squared. Now in my next example, I'm going to start out with a binomial, but this time I'm going to multiply it by a trinomial. So now instead of thinking FOIL, I just have to think about distributing twice. Distribute twice. So I start by distributing the first term here, x. That's going to be x times x squared is x to the third. Then x times 2x is 2x squared. Then x times negative 1 is negative x. Now I'm ready to distribute the other term in the first binomial. I'm now distributing the 3. 3 times x squared is plus 3x squared. 3 times 2x is plus 6x. And 3 times negative 1 is minus 3. Now I have to combine like terms. X to the third, there's only one with a cubed x to the third, so that's the only one. 2x squared plus 3x squared gives me 5x squared. Then I have negative x plus 6x. That's negative 1 plus 6. That's 5x. And then I have minus 3. I don't have any more like terms here, so this is going to be my final answer. Now the only thing I want to show you is when you see the original problems, you have to know that this is a multiplication problem, as opposed to this, which is subtraction, and this, which is addition. So you got to look really carefully to see that in this first problem, there's nothing in between the parentheses, which means I'm multiplying, which means I'm going to FOIL. But in the second problem, this would be what we did back a section or two, where we would take x plus 2 and we'd have to distribute the negative, minus x minus 3. And in this problem, the x's, x minus x, would cancel out, and we would have 2 minus 3 equaling negative 1. And in this third problem where we're adding, we'd have x plus 2 plus x plus 3. We'd combine the like terms. We are adding, not multiplying, so we'd have 2x plus 5. So I'm just trying to make the point that the problems look very similar, but you're doing something different. And you've got to look carefully to see if there's anything in between you're adding or subtracting. If not, then you're multiplying.